Hello and welcome back, future scientists. I'm Mr. K with Mississippi Public Broadcasting, and we're going to continue our breakdown of the science portion of the ACT today. We've done several passages. Today we're going to look at another one, and it's our job to try to find the correct answer, figure out how we got there, and take a moment and talk about why we got the question wrong. So what are we doing today? Well, today I would like you to find a partner again. Maybe find a different partner than last time. Your job is to, working together, I want you to justify the correct answer, explain why the other answers are not correct, and explain why you may have gotten the question wrong. Maybe it was a time management thing. Maybe you didn't understand what the question was asking. Maybe you were looking at the wrong part of the passage. So going through and practicing this stuff is going to help you down the line when you take the ACT for real. So what I'd like for you to do, go ahead and take all the time that you need, look at this next passage of the ACT, and then when you're ready, come back to me, and I'm going to break it down with y'all. All right, I'm sure that didn't give y'all any problem, but just in case it did, why don't y'all follow along with me? I'm going to break them down, and that way we're going to clear up any confusion that anybody might have. So let's go ahead and look at passage 5 of our practice portion of the ACT. This is question 28. It says, what is the approximate maximum A shown in figure 1 for a 200 hertz sound wave in air at 10% relative humidity, and at approximately what temperature does that maximum occur? The correct answer choice is F. A equals 3 and temperature equals -5 degrees Celsius. This question evaluates your ability to read a figure. It asks for the A value from figure 1 for a 200 hertz sound wave at 10% relative humidity. The legend indicates that the bottom curve corresponds to 200 hertz. The curve reaches a peak where A equals 3, which occurs at a temperature of -5 degrees Celsius. Therefore, the correct answer is F. So what's going on here is it wants to know the maximum that happened for a 200 hertz sound wave at 10% humidity. Well, if I'm looking at figure 1 over here, I can tell by looking at the key which one represents the 200 hertz sound wave. It's the bottom line here that has little dots in the middle of it. Okay, well then what I need to do, looking at only this bottommost line, I need to find where did it reach its peak, and I have it circled there. Okay, well now that I have it circled there, I can use that information and compare it to my answer choices to see what the correct answer is. The best answer here is F because that corresponds to the point on the graph where it has reached its maximum. I think that this part of the question that says a 200 hertz sound wave in air at 10% relative humidity, that might have confused some people because you're looking over the graph in the table to try to find where does it say 10% relative humidity. Well, I have that part circled up here in above the graph. It says all of these lines are dealing with air temperature at 10% relative humidity. So I circled that because I thought that might have confused some people. All right, so let's go on to the next one. Here's 29. 29 says, based on figure 2, the attenuation coefficient for a 1000 hertz sound wave in air at 20 degrees Celsius reaches a minimum value at a relative humidity closest to which of the following? The correct answer here is B, 45%. This question tests your ability to read a figure. The goal is to find the relative humidity for the 1000 hertz curve when the attenuation reaches its minimum. So this part that I have circled. According to the legend, the solid line corresponds to the 1000 hertz sound wave. The minimum attenuation value for this curve is just below 5. This minimum occurs at a relative humidity of 45%. Therefore, the correct answer is B. So again, what's going on? It's telling us what line and what figure to look at. I'm going to figure 2. I'm finding in the key which line corresponds to that 1000 hertz sound wave. That's the solid line. And then it wants to know when it reached its minimum. So I need to find where it has reached its lowest point, and I can see that that's about 45% relative humidity. Great job. I got a couple more to go along with this. So here's 30. 30 says, for the range of temperature and the range of relative humidity shown in figure 1 and 2, respectively, is A for a 200 hertz sound wave more strongly affected by changes in the temperature or by changes in relative humidity? The correct answer here is G. This question assesses your ability to compare two figures. In figure 1, the maximum variation for A for the 200 hertz sound wave is about 2.5. In figure 2, the maximum variation for A in the 200 hertz sound wave is around 0.5. This data shows the 200 hertz sound wave experiences more from the temperature than from the relative humidity. Again, what we're really doing here is we're looking at the 200 hertz sound wave for both figures and seeing which one had more fluctuations. You can see that in figure 1, it dips a lot in this circled portion. It goes from 3 to 0.5, and so that's a pretty big difference. When I look at figure 2, however, it's a steady decrease down that is going to not be as great of a difference there. All right, let's try our next one. So this is 31. Consider a 1,000 hertz sound wave in air at 10% relative humidity. At how many of the temperatures shown in figure 1 does A for this wave have a value of 18 dB over km? So what's going on here? And this is decibels per kilometer, okay, the dB over km. It says it in our passage. Okay, so what we want to do here, the correct answer is 4. The question tests your ability to interpret figure 1 to find how many times the 1,000 hertz curve intersects A at 18 decibels over kilometers. Draw a horizontal line at that level. The 1,000 hertz curve intersects this line 4 times, therefore the correct answer is 4. So again, it's telling us where to look. It wants us to know how many have a value of 18 decibels per kilometers. I find that value over here on figure 1. I draw a straight line through it, and I can see that the 1,000 hertz sound wave intersected it 4 times, and that means that 4 is going to be our correct answer there. Okay, here's our next one, 32. Suppose that two sound waves, a 150 hertz sound wave and a 1001 hertz sound wave, are simultaneously emitted from a speaker into air at 20 degrees Celsius and 45% relative humidity. Based on figure 2, as the wave travels away from the speaker, the intensity level of which wave will more likely decrease at the greater rate due to attenuation. The question tests your ability to project data from figure 2. The 150 hertz sound wave has a frequency slightly smaller than 200 hertz, and the 1001 hertz wave is slightly larger than the 1000 hertz. So we're going to use those as our base point. At 20 degrees Celsius and 45% humidity, the 200 hertz wave has an attenuation of 1 decibel per kilometer, while the 1000 hertz wave has a attenuation of 5 decibels per kilometer. Since the attenuation for the 1000 hertz wave is larger, the attenuation for the 1001 hertz wave is expected to be larger than that of the 150 hertz wave. Hence, the correct answer here is J. So again, we're looking at figure 2. We don't have a line for 1001 and for 150, but they're pretty close to information that we already have. So we're going to use the 1000 to represent the 1001, and we're going to use the 200 hertz sound wave to represent the 150. We can use that information and line it up here at 45 degrees relative humidity, and that's going to help us find the correct answer. You can see here that the 1000 would be greater than the 200, and so that means that J is going to be the correct answer. When they ask you a question about information that's not here, you can see that the question here says suppose. So it's saying, like, if we did another experiment and it was kind of similar to this, what would the answer then be? Well, they're not going to throw you a curveball and change up the trend. Because we have data that's pretty close to what it's asking, we can use that and extrapolate data from it and make an educated guess. That's what this answer is. It's an educated guess because we don't actually know. It's not on the graph anywhere, but we're using the information that we have to make an educated guess. And the best guess here is going to be J. All right, y'all, here's the last question for passage 5. This is 33. It says, the graph below shows for sound waves of 3 different frequencies how the attenuation varies with relative humidity in air at a particular temperature. Based on figure 1, the particular air temperature is most likely which of the following? Our answer choice here is B for 0 degrees Celsius. This question tests your ability to apply information from one figure to analyze another figure. Figure 1 shows data collected at 10% relative humidity, and the new figure, the attenuation values are 14 dB over km for 1,000, 9, and 3 for 200. In figure 1, these attenuation values for the respective curves occur at a temperature of 0 degrees Celsius. Hence, the correct answer is B for 0 degrees Celsius. So again, what's going on here is when I look at this graph under 33, I can see what these values are for 10% relative humidity. You can see that the top one is about 14, the middle one is 9, and then the bottom one is 3. If I take that information and compare it to 0 degrees temperature on figure 1, I can see that I'm getting the same values. And so that tells me that this test was probably done at 0 degrees Celsius because these two pieces of information are the same. All right, y'all, so thank you so much for following along with me today. Your teacher has some other work for you to practice on, so make sure to give that your best effort, and I hope everybody has a great day.